Yep, thank you very much. Okay, so my focus for many, many years, been in the industry for a long time, has always been on the financials of implementing renewable energy solutions, right? Everybody wants to do the right thing, but we all have budgets, right? So as our first speaker noted, the opportunity here is that the cost of energy has gone up dramatically in the last, 10 years, right? The last 4 years, it's moved extremely quickly, right? So now there is an opportunity for us to take advantage of these renewable energy technologies, and it makes sense to the bottom line, right? So UHRIG is, yeah. Down there. There we go. Yeah. All right. So UHRIG is located in Germany. They've been in the wastewater industry their entire life, since the 60s. They design and implement wastewater systems, right? So as the story goes, one of the founders of UHRIG was having a beer with a physicist, and they decided, you know what, there's a lot of energy in this water. We should design systems to address this and take care of it. Their goal was design something that was passive, that wouldn't fail, right? That didn't have to be maintained, didn't have to be, it didn't require energy to operate. So they came up with a system called the thermline, right? So I thank my predecessors this morning for explaining heat pumps and how much energy there is in wastewater, so I don't have to recover that, right? So I'll just dive right into what we do and save some time, right? So it's a pretty elegant system, pretty elegant design. It's basically a heat exchanger that's custom designed for the sewer, that fits right in the bottom of the pipe, right? So you have this constant water flow, this constant energy flow over a very thin, high quality stainless steel heat exchanger, right? So the examples that you see here are basically thin, layered heat exchangers, right? Which either water or glycol will flow through. And that energy is then brought into the building through lateral connections, right? So it's just it's a closed loop source of energy being provided to your heat pump. And then the heat pump is just utilizing that, just as it would a ground source system, utilizing that to bring energy into your building, right? It's a pretty simple approach, right? The biggest challenge here, of course, is we're a German company. The technology is used far and wide in Europe, right? There's hundreds of installations in Europe that are running flawlessly with no problems, no failures over the life of the system. But in America, this is new to us, right? So there's a lot of education that has to be taking place, right? So we're in the process of connecting our operations teams here in the US that are operating wastewater treatment facilities with their peers in Europe to discuss how it's been working for them and what kind of efficiencies and reliabilities and repeatabilities they're seeing in their systems, right? So the way the system architects is you have your wastewater treatment facility that's delivering your energy. There's a power plant that is if we go back here, which is basically your heat pump and your lateral, right? And then energy is being provided to a building, right? A commercial office space or a facility that requires heating and cooling, or it could be the wastewater treatment plant itself, right? Normally, we look for systems that are pipes that are of 30 inches in diameter, right? With a minimum water flow of 10 liters per second. Now, that resource, if you will, could be anywhere from really close to up to 3,000 feet away, right? Because remember, we're just moving water, right, or glycol through the loop, and we're providing that energy to the heat pump for use. This is an example of two systems that we've I pulled from the European market, right? One was a thermal output of 2 megawatts, and the other one is a thermal output of 300 kW. You can see that we've used two different thermliner designs. The liners, if you will, are if we go back to this right here, the liners, if you will, are custom made, right? Based on the architecture of the sewer that we're putting the systems in, and then they're put into the sewer. They're put into the system in sections, right? So the thermliners are they're lowered in through a manhole, so there's no other infrastructure that has to be implemented or designed or dug up. The streets don't have to be tarnished in any way. Thermliners are lowered in through a manhole. They slide them down into place, and then they're connected one by one, you know, in a fashion that results in a large, you know, dynamic heat exchanger that's being built in the sewer and sitting on the base in the bottom. And the heat exchangers are designed in size based on the need of the plant that you're trying to build, right? So if you're building a small system, it's a shorter heat exchanger with lesser sections. If it's a larger system that requires more energy, it's a larger heat exchanger that spans more of the base of the sewer, right? Getting back to the earlier comment, which is we're really dealing with geothermal impacts that are going on here. One of the common questions I get is, what happens if you install a heat exchanger here and then downstream you want to capture more energy from the water somewhere else in the city or municipality, right? Well, if you think about it, these sewer pipes are 30 feet below the ground, right? So they're constantly exchanging thermal energy with the earth, right? So it doesn't take long before the water regains its thermal mass after it's run over a thermliner, right? So one of the other common questions I get is, well, how is the system, you know, deal with things that are coming down the pipe, right? The thermliners are extremely thin and they're ramped at both sides, right? So if you talk to our European owners of these systems, you'll find out that virtually nothing sticks to them. Things don't get caught on them. They flow over and flow past the thermliner, right? Now there is a biofilm effect, right? So when you install these systems, you do have, when they first go in, they actually overperform. So the biofilm effect is part of our engineering process. We know what the biofilm is going to do from a energy reduction perspective. We use that as part of our design criteria. So we design a system that we know after it's been coated with biofilm, it's going to perform at a certain energy capacity that is our design criteria. So when the system first goes in, it's normally overperforming. Then the biofilm effect kicks in, and we're now performing to spec, and the systems are virtually maintenance-free at that point. We do go in and we look at them like every 5 years, but we've never had to maintain them in any fashion. We don't recommend that they need to be cleaned. If you happen to be cleaning the sewer, that's fine. But none of that has to be addressed once the system is operational. So how are they secured? The therm liners are secured either by expansion anchor or by something we call quick block sleeves, and that depends on the architecture of the sewer, right? The quick block sleeve is just a large stainless steel band, right, that expands inside the sewer and holds the thermal liner down to the bottom. So between that and some expansion anchors, it holds the system in place, and they stay where they're put. And they, like I said, we've had systems in operation in Germany, Switzerland, Austria, Paris, France, for 20 years. So as you can see, that the way the water would flow, you have, your supply coming in from the heat exchanger on the street, from the heat exchanger in the building, from your heat pump in the building to your thermal liner out on the street, and then returning back to the heat pump in heating season with energy, in cooling season, dumping energy into the sewer water. Now, the installation process of the thermal liner does require dry conditions during the install, and we normally take care of that with a bypass during the install process. And that's a picture of a bypass system in place. This is an example of how the ramps are put in place. So every thermal liner system is designed that goes into the sewers. Pipes are designed with ramps in place at both the front and the back of the system. And you can see at the bottom, those are examples of systems installed. The one on the left you'll see is more of a system where fasteners were used to hold it in place, and the one on the right is the stainless steel quick locks that hold it in place. But each therm liner system is custom designed and delivered in sections and installed in sections. When the systems are installed, that what I call the laterals, or the piping that goes from the building, from the heat pump to the therm liner in the street, consists of 3 pipes. One of them is a supply, one of them is a return, the third one is controls, right, and monitoring. So your system is constantly monitoring the water temperature in the sewer, and the supply and return temperatures that are going out and coming back to the heat pump. That's an example of the install of the 3 pipes. And that's pretty much it.